Okay, this is the video. We're going to continue to do tic-tac-toe problems, and we're going to do numbers 6 through 12. So they want us to find the sum given n equals 1 to 15 of the explicit is 3n, and they want us to find the sum. So if we remember, it's a finite because we know where it stops. The finite sum for an arithmetic, how do I know it's an arithmetic? Well, because n is not an exponent. If n was an exponent, it would be a geometric. In this case, n is not an exponent, so it's an arithmetic. So I have n over 2 times a sub 1 plus a sub n, first term plus last term. And right now we want to figure out the sum of 15 terms from 1 to 15. So that's 15 over 2, a sub 1 plus a sub n. Well, how can I find those? Well, a sub 1 is when you plug in 1 for n. So a sub 1 is 3. It's 3 times 1. A sub 2, or sorry, a sub 15, which is the last term, you plug in 15 for n. So 3 times 15, that's 45. So we have 3 plus 45, 15 over 2 is 7.5. 3 plus 45, and that's going to be 360. Alrighty, so that's number 6. Let's do number 7. Number 7, they're asking us to find the geometric mean given 8 and 40.5. And if you look at the worksheet, the question, they're asking you to pretty much multiply and take the square root. So 8 times 40.5 is blah blah blah, the square root of that. I think you should get 18 at the end, and that's number 7. Number 8 is a very straightforward question. It's giving you the explicit formula and asking you what's the common ratio. Well, if the explicit formula is 4, -3, n minus 1, then the ratio is the base. So the base of the n minus 1. So r is -3, and that's all they wanted. Alrighty, number 9. They're giving us the pattern, and they want the sum of the geometric series. Well, I know the formula was given also. A sub 1 minus r power n over 1 minus r. Well, if we look at it, we have a sub 1. We know r. Looks like it's, dividing by 2 or multiplying by half. So we have actually negative a half because we have alternating negatives. Negative a half. And we have n missing. So we don't know how many terms that is. Well, how do we figure out the number of terms? Well, we have the last term. That's helpful. I know in a geometric, the explicit is a sub n, a1, r power n minus 1. Well, a sub n is -6. R is a half. A sub 1 is -6, r is a half, n minus 1. Well, a sub n, if I look at the last term to figure out how many terms, I can figure out what's the position of the last, because that's going to tell me how many terms there is. If the last term is number 50, then I have 50 terms. So I know that 3 over 16 is the last term, and I want to solve for n. Well, if I divide by -6 or multiply by 1 over 6 to get rid of that, because I want the base by itself, because I'll be using logs to solve for the exponent, I'll have divide by -6 or multiply by -1 over 6. So I'll have -0.03125. And that's equal to -0.5 power n minus 1. Well, I know logs don't take negatives, and actually the negative here is just to alternate negatives in the pattern, like negative, positive, negative, positive, negative, positive, just alternates it, but doesn't change the value of the actual numbers. So the actual numbers are actually not going to change if it's a negative a half or just a half. So the negative, is just alternating negatives. So I can ignore the negatives when I'm putting into log, and it shouldn't change anything. So log, again, there shouldn't be negatives in front of the logs because it's not going to calculate. It's going to give you an error. And that's equal to the exponent. If you calculate that, you should get n minus 1 equals, let me do it. So that whole mess will get me equals to 5. And then I add the 1, so I get n equals 6. So I have 6 terms. That's the 6th term. So number 6. Okay, so we have 6 terms, we have R, we have A. We can just plug it all in our calculator, and remember to do the top, then equals, divide by, and you do 1 minus negative a half, or 1 plus a half, which is 1.5, and all of this should get you negative 3.9 something. Alrighty, hope this helps. Let's do number 10. Number 10, they said that the first term given to us in a geometric sequence, first term is 2, last term a sub, I don't know, last term 32, and a common ratio, negative 2. So I don't know what's the position of that number 32 because they said it's the last term, a sub n. Well, I don't know what n is. But I know that this is what they're asking. They want to know how many terms. So I know that a sub n equals to a sub 1 r power n minus 1 in a geometric sequence. That's the explicit formula. So a sub 1 is 2, r is negative 2, and minus 1. Okay, they want to figure out how many terms. Well, I know that 32 is the last term. If I can figure out the position of that last term, I'll know how many terms that is. So let's divide by 2 so that we can get the base by itself. And you'll have 16 equals negative 2 power n minus 1. Again, like the last problem, the negative doesn't change the value when you're doing geometric. When you multiply by a negative, it's just, negative times a negative is a positive. Positive times a negative is a negative. It just alternates. The negative comes and goes. But the value of the number doesn't change. So I know that, for example, 2 times 2 is 4. 2 times negative 2 is negative 4, but it's still 4. It's just a negative. So the negative doesn't change anything. So I can just ignore it when I'm doing logs. Not that, any negative you should ignore, but in that case, because, it just alternates negative, it doesn't change the value, you can. And that was the tricky thing. Log base 2 of 16 equals n minus 1. Well, I know that 2 power 4 is 16. So log base 2 of 16, that's 4, equals n minus 1. And if I add the 1, I'll get n equals 5. So there are 5 terms in that sequence because the last term is the 5th term, so I have 5 terms. Okay, number 11. Okay, so you have, they want the sum, and looks like a geometric here of from 1 to 4. So you can figure it out by doing, plugging in 1. It's just 4 terms. So you can say, all right, well, plug in 1, we'll get a sub 1, a sub 2, a sub 3, a sub 4, and, I'll do it that way, which is, for 4 terms, it's manageable. Which you can. So 1 minus 1, that's 0. So the first term is just 20, because a quarter power 0 is 1. Second term is when we plug in 2, so 2 minus 1 is 1, so 2 times a quarter is 5. Second one is when you plug in 3, so 3 minus 1, that's 2, so a quarter power 2 is 1/8, so okay, sorry, 1/16. A quarter power 2 is 1/16, and that's a common error, like we followed in it all the time. Okay, so 20 over 16, not an 8. because again, a quarter power 2 is like a quarter times a quarter, which is 1/16. So sorry about that. Okay, so if we divide them both by 4, we'll get 5/4. Alright, so 4 minus 1, that's 1/4 power 3, so 64, so 20 over 64, and we reduce. You have 5 over 16, and you just add them, and it's not going to be fun, huh? Well, 25, 20 plus 5 is 25, plus we have, you know, if you want to get a common denominator of 16, you'll have 25 over 16, and it's kind of a pain, but you know, it's possible. We'll do it with the formula also, just to see that we got the same answer and we see it works both ways. Okay, so anyway, so that's 20 and 5 is 25 over 16, so we have 25 plus 25 over 16. Well, that can be, we can get a common denominator and make it 400 over 16, which is 25. So it's 425 over 16. So that thing can be switched to 400 over 16 plus 25 over 16, 425 over 16 is our final answer. Well, let's see if we can just, you know, figure it out with the formula also, just to verify. So if we try the formula, let's see if I can try S sub 4 equals A sub 1, in that case is 20, 1 minus a quarter power 4 all over 1 minus a quarter, or 3/4. So you have 1 minus a quarter power 4 times 20, 1 over 3/4, which should get you 26.5625, which is the same as this one. So if you plug that in your calculator, 425 divided 16, it's the same thing, 26.5625. That's it. You can work it out as a fraction as well. Okay, number 12 is kind of a, you know, just funny question, I think, in my opinion. Number 12, they're telling you that A sub 7 is 14, and that's the last term. So how many terms? Well, if the last term is in the 7th position, then there are 7 terms. Alrighty, thank you. Good luck. Bye.